Hey guys, we're on the back side of Unit 6, Day 5 notes, and number 4 says one of the medical uses of iodine 131, a radioactive isotope of iodine, is to enhance X-ray images. It says that the half-life of I-131 is approximately 8.02 days. A patient is injected with 20 milligrams of I-131. And they want you to determine to the nearest day the amount of time needed before the amount of I-131 in the patient's body is approximately 7 milligrams. Okay. All right, so hopefully you know that this is our last formula on our formula sheet, and that's our half-life formula. So we'll say A of T is equal to A sub 0, in parentheses is 0.5, and then it's raised to the T divided by H. So we have A of T, we have A sub 0, we have T, and we have H. All right, so it said that the half-life is 8.02 days, and so that's our H, and that's 8.02 days. And I write the word days because our T has to be in the same time frame. A patient is injected with 20 milligrams, so that's our initial amount. And they want us to determine to the nearest day, which is our time. Okay, and so remember that because our H is in days, T will come out in days. The amount of time needed before the amount in the patient's body is approximately 7 milligrams. And so that's the final amount of the I-131, which is our A of T. All right, we're ready to go ahead and plug in. So we'll say 7 equals 20, in parentheses is 0.5, and then raised to the T, because we don't know it, divided by 8.02. All right, again, we're solving for an exponent. We know we need logs. However, 20 is an extra, and so we need to divide by 20. Okay. You could put it in your calculator. It's an ugly decimal, so if you math frac it, it's still 7 over 20. So it's up to you what you want to use, if you want to use the decimal or if you want to use the fraction. This is going to be 0.5 still. This is going to be T divided by 8.02. Okay, so now we're ready for logs. So we're going to write log. Our base or subscript on the G there is 0.5. Our number is 7 over 20. And we're equal to the exponent, which is T divided by 8.02. Okay. Why that helps is that this can be put in our calculator as long as we change it into a log divided by a log problem. On the top log will be 7 divided by 20, and on the bottom is our base, which is 0.5. All right, so we'll type this left-hand side in. And when we are finished, we will get 1.5, 145 ... equal to T divided by 8.02. All right, there's a couple things you could do to solve. You could put the 1.5 decimal number over 1 and cross multiply, because you'll have a fraction equal to a fraction. Or you can just realize, hey, T is being divided by 8.02, so the opposite of dividing by 8.02 is to multiply by 8.02. Okay, and when we multiply, that would cancel, leaving us with T equals, and 8.02 times that 1.5 decimal number is 12.1468, ... And the rounding direction set to the nearest day, which is the 2 spot. Look next door and won't round it up. And so we'll say T equals 12 days. And again, they said approximately because 12 actually won't make it reach 7, but it'll be very close to 7, okay? So they said that's why they said approximately 7 milligrams, all right? It won't exactly be 7 when we substitute our T of 12 in, all right? But it'll be close enough, and that's why they said approximately. All right, good job. Let's try the next one. Okay, number 5. It says that Seth's parents gave him $5,000 to invest for his 16th birthday. He's considering 2 investment options. His first one is option A, and it will pay him 4.5% interest compounded annually. And his option B will pay him 4.6% compounded quarterly. They want us to write a function of option A and option B that calculates the value of each account after n years. Okay, all right, so let's take a look at what we highlighted in red for option A. That's compounded annually. Annually is once a year, all right? So that word annually refers to an n value equaling 1. Okay, and so we'll use our formula, the second one down, for compounding. And that formula is A of t equal to P, 1 plus R over N raised to the NT. Okay, and so when we fill in our information, we'll have A of t equal to our principal, which is 5,000. In parentheses will be 1 plus. Our rate for option A will be 4.5%, so 0.045. All divided by n, which we said was 1 for annually, and then raised to the 1. And they want us to use n for years instead of t. So that's 1n. Okay. Technically, because n is 1, this would simplify a bit. Okay. 0.045 divided by 1 is just 0.045. So if we wanted to, we could clean this up a little bit. Okay. That's what it would be in parentheses. And 1n is just really n. And so that would be a simpler form of our option A function. Okay. Either one, though, you could have left it as the one above it. It doesn't matter. All right, option B. We put that in green, so we'll do this one in green. This is compounded quarterly, so it's actually the same formula. So we'll say B of t, though, just so we can indicate that it's option B. Same amount we're putting in, 5,000. Same 1 plus. But in option B, what we have highlighted is 4.6%, so that'd be 0.046. Okay. Divided by so because they said compounded quarterly, quarterly refers to the number 4, because quarterly means 4 times a year, so that's n equals 4. So put the 4 here, and then raise it to the NT. So remember, n is 4. However, they don't want us to use t for time. They want us to use n for our years, so that'd be 4n. And technically, I'm going to have to change one more thing that I didn't realize because they're changing t to n. I got to go and change this t in here. Nope, how come this isn't changing? My eraser. I need to get rid of, oh, it's not going to let me change that. Maybe it'll let me change this one. Nope. All right, so I'm just going to go ahead and write right over it. So technically, because they're not using t, they're using n, we got to change this to an n. Okay, so it makes sense. So the variable that's in parentheses should be the variable that you're using in your equation. So we'll just go back and change that. Good catch. All right, and now they are good to go. All right, and there, we'll box this one in. And that's my option B function. All right, so in the next part, it says that Seth plans to use the money after he graduates from college in 6 years. Oops, again, not what I wanted to do. They want you to determine how much more money option B will earn than option A to the nearest cents. All right, so we're going to take our option A formula. So this will be A of 6, or you just say A of n. It does not matter. It's not going to affect your answer. Okay, so we'll say A of 6. You keep it A of n. It doesn't matter. 5,000, 1.045 raised to the 6. Okay, and we'll go ahead and type that right in. 5,000 in parentheses, 1.045. Close it, raise it to the 6. Okay, and that's going to end up with 6,511.300624. Okay. For option B, also n is 6. 0, 6 divided by 4, raised to the 4 times 6. All right, we can just type that in exactly how it's written. So 5,000, open the parenthesis, 1 plus 0.046, divide by 4, close it, raise it to the 4 times 6. And hit enter, you should end up with 6,578.869 ... And we have to remember that they're looking for how much more, okay? How much more will option B earn than option A to the nearest cent? So what that means is that we need some subtraction. So we're going to go ahead and take our higher number, which is option B, which they told us option B would be earning more money than option A. So that's good, a good check. So we're going to go ahead and take our 6,578.869 ... minus our 6,511.300 ... Remember, no rounding to the end. Okay? And that gives us 67.569 ... And now that's our final answer. And they want it to the nearest cent, which is the nearest hundredth. We'll look next door, and that's going to round it up. And so we'll say final answer is $67.57. And that's how much more money option B earned than option A. Okay. All right. One more part to this question, and it says algebraically determine to the nearest tenth of a year how long it would take for option B to double Seth's initial investment. So remember, what was Seth's initial investment? All the way back at the top, it was $5,000. So $5,000 double means to multiply by 2 will give you 10,000. All right, and they also said for option B, we want option B. All right, so we got to go up for option B's formula that you wrote in the very first part. And that formula was B of T equals 5,000, 1 plus 0.046 divided by 4 raised to the 4n. Oops, this was an n. Okay, and we're going to take that final amount out anyways, and we're going to put in 10,000. And we're going to solve for n. And notice n is an exponent, and that is why we need logs in this question. Okay, but before we get to log form, we're going to divide by 5,000. So we have our 3 items to put into log form. 10,000 divided by 5,000 is a nice old 2. And I'm going to go ahead and type what I have here in parentheses to clean up this space. So that's just one single number instead of 1 plus 0.046 divided by 4. And when I type it in, it gives me a 1.0115, and it's still raised to the 4n. And now I'm ready for logs. So we write the word log. Our base is 1.0115. Our number is 2, and it's equal to our exponent of 4n. Okay. Again, we're going to put that into our calculator by changing it into a log divided by a log. 2 would be on top. 1.0115 is on the bottom. Okay. Once I type it in, I end up with 60.6195 equal to 4n. I'm going to then divide by 4 so that I can figure out that n, the number of years, is 15.1548 ... Rounding direction said nearest tenth. Look next door, and that's going to round it up. And so we'll say n equals 15.2 years. And that's how long it's going to take him for using option B to double his money. All right. I will see you guys on day 6 for our notes then. All right, guys, bye.